Okay, exam 3 from spring 20. Which of these statements about a household circuit is true? The household circuit is a series circuit? Nope, it's a parallel circuit. All devices in a household circuit operate at the same current? Nope, they operate at the same voltage. As you add more devices to a household current circuit, the total current increases. That's true. And a GFCI turns off if IN exceeds I out for any particular device. That's also true. So 3 and 4 are the right answers here. So notice here that the GFCI and the circuit breaker look really similar. If it was a circuit breaker, it would say if the current exceeds some maximum current. Okay, so on a circuit breaker, you have a 1200 watt heater and you have these other devices, and I want to know if you turn on the blender, it turns off, what is the maximum allowed current? So we find the current for each individual device. I is equal to P divided by V. So that's 1200 here divided by 120 volts, and that's equal to what? 10 amps. So I have 10, I have a half, and I have 2 amps. So for those, I have 12.5 amps. And then I add this, which is, what is that, 180 over 120, which is 6 over 4th. So this is equal to 1.5. So 12.5 to 12.5 plus 1.5, which is 14 amps. So somewhere in between that, somewhere more than 12 and a half, but less than 14. So B is the right answer. Which purpose does a GFCI serve? Not to protect from too much current, that would be a circuit breaker. Not an alternate path, that would be the ground on that third prong. Protect the user from severe electrical shock. That is correct. And it's not D, that would be a circuit breaker as well. So protect the user from severe electrical shock. All right, which of these equations is correct? Let's just take one by one. 14 minus 4I1 plus 6I3. So 14, starting in this way because it's positive, minus 4I1 plus 6I3. That's supposed to be down here, but notice that's not a resistor, so this one is not right. 14 minus 4I3 plus 6. 14 minus 4I3. That would be correct, except it shouldn't be I3. It should be I1. And then minus 6 plus 10. So that's going to be going in this direction because it's minus 6. So minus 6 plus 10, that's correct so far, plus 6I2. Ooh, looks like we got a correct one right there. So C is the right one. What is the magnitude and direction of I2? Okay, so I want to know I2. I want to figure out what is the best loop to use to find I2. And it's going to be this bottom loop. Notice because there's no resistor in this bottom part right here, so therefore my equation is only going to have I2 in it. So I'm going to start right here. I'll go in this direction. So I'll have minus 6I2, minus 10. Because I'm going from high to low, I have a negative potential. And then over here it's going to be plus 6. And that's equal to 0. It's 6 because I'm going from low up to high potential. Alright, so that's minus 6I2 minus 4 equals 0. I2 equals negative 4 over 6, or 2/3, or negative 0.67767. So it should be to the right. Notice here that I2 is to the left, but since it came out negative, it's going to be the opposite direction. So D is the right answer. You would have known that just because of the magnitude, but I might have had 0.67 to the right and to the left, and then you have to pick it out based on is it positive or negative. I've been known to do that before. All right, so number 5 is D. Number 6, consider this circuit. I2 is 0.17. I'm just going to write that here. What is the magnitude of I3? So again, we're going to use the bottom loop because I3 is included in the bottom loop, and that's just going to be the easiest equation. So I'll start here and I'll go in this direction. Minus 6I2 minus 5 plus 6 equals 0. Actually, no, never mind. I'm sorry. So what I have to do here, I'm looking for I3. Notice this doesn't have I3. In fact, this equation doesn't really help me at all because I know what I2 is, so I don't really need this equation at all. And so if I have a loop that doesn't have a resistor in it, and I need to find its current, then I'm going to have to use the junction rule because that'll be the only other equation where that current shows up. So I'm going to write the junction rule right here. I have I1 and I2 entering, and then I have I3 leaving. Okay, so I3, or I2 then, will be equal to I3 minus I1. I'm sorry. I3 is equal to the sum of I1 plus I2. Sorry about that. I don't know why I'm so fixated on I2, for goodness sake. Anyway, so if I find I1, then I can find I3, because it's just going to, I already know I2. So let's take either the big loop or the top loop. I'm just going to take the big loop. For no particular reason. I could do the top loop as well if I wanted. Okay, so I'm going to start right here. I'll go in that direction. I will have 3 minus 2I1 plus 6 equals to 0. And so minus 2I1 equals minus 9. I1 equals 4.5. And so to find I2, excuse me, I3, to find I3, I do the sum of 4.5, sorry, 4.5 sorry, I'm having technical difficulties here. I'm going to pause this, I'll sort this out. Back to you. Okay, so I'm still having some difficulties. I'm going to just finish this question, then I'll start another video. So the answer for I3 is the sum of I1 and I2. It's going to be 4.5 plus 0.17, which is 4.7, 4.67, or 4.7. So the right answer here is going to be 4.7 amps.